So, good morning to all of you. The topic which we are going to discuss today is co-integration. And after that, we will discuss the vector error correction model, which is the extension of co-integration. Co-integration is very unique topic, one of the unique topic in financial econometrics. And it gives you the clarity about the long-term relationship. Because most of the scholars, so they become confused that what is actually the meaning of long-term relationship. So this is the only technique in financial econometrics which gives this clarity to you. So that's why I assume that this is a very, very important topic in the finance. Okay. So the Angel and Granger, they gave this topic. And the way they explained the topic, I'm just trying to explain it. Assume that there is a lady and she is walking with a dog. Because this is the concept which is defined in this manner. So if you need to understand the concept, so you need to imagine the example. So imagine that there is a lady and she is walking in an open ground and she is having a dog. So walking in a huge ground. Now, if I ask you that what kind of movement they may have, that is very, very important. And I just ask you to think about these movements. That can they walk in a straight line? Or they walk in a zigzag way? What is the distance between the two? So do you think the lady and the dog maintain the same distance throughout the walk? Or is it possible that dog ran away from the lady? Sometimes it may happen that lady want to move in south direction and dog want to move in north direction. So how they manage? Because both want to move in opposite direction. So what kind of movement they can have? So let me explain the movement. So these are the observations that we have about the movement of a lady and the dog. So in this picture, the dog is very small because the picture I get from the Google is like this. Otherwise, this is not a compulsion. Assume that the dog is also a big dog. So assume that dog is also big, not as small as in the picture. So first observation that I can say about the movement is the lady and the dog cannot walk in a straight line. It is not possible. Like if I ask you to walk alone, you can walk in a straight line. But when you walk with somebody else, especially like a dog, it is just impossible that the movement in an open ground, the movement in a straight line is not possible. So both are moving randomly, zigzag manner. So the first observation is that the both lady and the dog are moving zigzag, which is known as random walk with time. So this is one of the feature of co-integration, that whenever two series are moving randomly or whenever the two time series are non-stationary, then co-integration is applicable. This is the conclusion number one from the observation. Number two, they maintain the long-term relationship, right? And the maximum distance between them is the length of the chain. Especially when the dog want to move in south direction and the lady want to move in north direction, the maximum distance between them could be the length of the chain. But what is important here, that lady is not leaving the chain. Lady is holding the chain tightly. Why? Because they want to maintain the long-term relationship. So when these kind of condition comes, when both want to move in opposite direction, after some time, you can imagine After some time, either the lady will compromise or the dog will compromise, and they both started to walk in the same direction. So conflict comes, and when this conflict comes, the maximum distance they can have is the length of the chain. And after some time, so when they know that they cannot move in opposite direction, any one of them is will compromise. It depends upon the strength of the. If the lady is very strong, she will pull the dog. If the dog is very strong, the dog will pull the lady. But one has to compromise. So in co-integrating relationship, if you have two or more variables, right? So one variable is dominating variable and another variable is compromising variable. So this is the nature of the long-term relationship. Because if both are dominating, they cannot hold the long-term relationship. In long-term relationship, it is compulsory that any one series has to compromise. And this correction, this compromise is known as error correction mechanism. Now it depends upon that which series will correct the error. So now we are drawing a very important conclusion from this, that long-term relationship is not possible without compromise. Somebody has to compromise if they want to have long-term relationship. Okay, so sometimes the lady follow the dog and sometimes she pull the dog. In long-term relationship, it is always. Sometimes one variable is dominating and other is compromising. Sometimes other variable is dominating and first variable is compromising. If both want to move in opposite direction, then somebody has to compromise. But both will maintain the balance. This balancing is very important. So if this balancing is absent, long-term relationship is not there. So to maintain the long-term relationship, there must be some error correction mechanism. And this error correction mechanism is the guarantee of long-term relationship. So whenever you say long-term relationship between the variables, you have to define what is the error correction mechanism in the relationship. If you don't have any definition of or explanation of error correction mechanism, the long-term relationship is not possible. So these are few of the observations that we have about the lady and the dog. So on the basis of their movement, now we have some conclusion. So two or more financial time series are said to be co-integrated. Co-integration means long-term equilibrium relationship. So two or more financial time series are said to be co-integrated or have long-term equilibrium relationship if both are non-stationary in nature and same order of integration. Both are either I1 series. Most of the time, more than 90% of the cases, both the series are I1. So you cannot apply co-integration on the stationary series. So you have to remember that. Co-integration is not applicable on stationary series. So you have to remember that. The first condition is that both should be non-stationary. If you remember, dog and the lady cannot move in a constant line. So they must move randomly. Both the series are maintaining the long-term relationship, long-term equilibrium relationship. And how this long-term equilibrium relationship is defined is that in case some disequilibrium or disturbance comes in the equilibrium relationship, it will be corrected soon with an error correction mechanism. And because of this error correction mechanism, the relationship will continue. Okay. So now I'm giving you few examples of this long-term relationship. So financial time series, some of the financial time series also found to have long-term equilibrium relationship. By equilibrium, we mean relationship which will hold an average over a longer period of time. So this relationship will continue for a long period of time. Whenever this equilibrium starts, the process of error correction starts. And it is very, very useful in understanding the long-term equilibrium between financial time series. Also, co-integration is one of the very popular trading strategy. And all these things I will explain. So let's explain with some example. You know that there are two markets. The first example which I'm explaining is spot and future market in derivatives. A spot market is known as mandi, where you can buy and buy the goods. You can go to sabji mandi or any other mandi. And sabji mandi is vegetable market is very, very popular form of spot market. You can go there, buy the vegetable you want. But the traders, they don't buy from these market, they buy from the online market. And for them, we are having some commodity market. So they buy the vegetables from the commodity markets. That is called future market. Because if you place the order, you will get the vegetable after 3 months or 2 months, and that is called the time of delivery. So we are having two type of market: spot market and future market. And those who understand the mechanism, they know that future price of the vegetable or of a commodity is equal to a spot price plus cost of carry. Means, suppose you need to deliver the vegetable after 2 months. So we assume that you have to buy the vegetables today. So that is the spot price. Plus you have to bear some storage cost. The amount you invested, you will not get the interest cost. So that is the cost of carry. Cost of carry is simply the addition of two things: the storage cost and the interest cost. So spot price plus cost of carry is equal to future price. That is the minimum price you charge. So ideally, the future price should be equal to spot plus cost of carry. So we can say there should be a long-term relationship between the future price and the spot price. Now, I'm explaining the concept of disturbance. So what happens? There are three types of participants in the market. One is the trader who actually buy and sell the goods. The second person is a speculator who analyze that future market, and if they think the price will go up, they buy from the future market. So buying the future market is known as long position. In technical terms, we call it long position. Long position means you are buying the vegetable or commodity in the future market, especially when you feel the price will go up. Normally the price will go up. And sometimes if demand is too high, then definitely the prices go up. Like if we have the prices like onions, guar seed, corn. So these are fast moving goods and the prices normally increases. Similarly, if there is a bumper production of any commodity, of any vegetable, then they know that the price is going to decline. So sometimes we are having tomato, onion bumper production because of the heavy rains. So then the speculators know that the price are going to fall, so we should sell. So they take a short position in the market. The third kind of participants are known as arbitragers. So these arbitragers have a eye. They are having the algorithm softwares. And so that is called algo trading. So most of the arbitragers, they are using the algo softwares, which tells them that if you buy and sell in spot and future market, this is the profit you can make. So whenever they found that there is a difference between the spot price and the future price, they buy from cheap market and sell in the costly market. And the difference which we are making is called arbitrage profit. So this is called arbitrage trading. So now if I ask a simple question, so assume that there is a commodity X in the spot in the commodity market, commodity X. Now the news is coming, there is a shortage of rain in the area where the production is going on. Shortage of rain, it means the production will be less. Means the price of the commodity will going to increase. if you have this information, you have two options. Number one, buy the commodity from the spot market, hold it and sell it when it comes, when the price increases. So this is the easiest option. But the problem is that government is against this activity. So if government knows that you buy a lot of commodity in your godown, so they will raid and seize all the commodities, because these activities are not promoted by the government. So these are risky things. So buying the commodity from the spot market and holding it for some time is not allowed. And maybe you need a huge cost of that. You need to have bear storage cost, insurance cost, and so many other costs, security cost. So most of the traders, they do what they take a long position in the market. So informed traders, so these traders which understand the market and they know that the price will increase, so these traders are known as informed traders. So these traders will take a long position in the future market. They don't touch the spot market, they take the long position in the future market. And now think, when they are taking the future position in the future market, the future price will increase. Slowly and slowly, future price will increase. Okay, now the story is not end here. The farmers or the traders who are selling in the spot market, so when they see the market in the future price in the future market is going up, so why to sell cheap in the spot market? So they also start increasing the price in the spot market, because the price in the future market is increasing because of the heavy demand by the traders in future market. This is called correction mechanism. Because any new news have a impact on the trading activity of the traders, arbitrators, and the speculators. So the traders in the spot market will also react that. That reaction is called error correction mechanism. So most of the studies on derivatives applied the cointegration. Now, if you think the commodity market and the equity market, in commodity market, most of the time, spot market correct the future market. Most of the time, almost 80% of the commodity. But now there are some commodities which are not available in the spot market, like energy trading, electricity trading, natural gas trading. You cannot buy all the commodities in the spot market. The spot market is there, but at institutional level. So in these commodities, the spot market is dominating and the future market is correcting the error, especially the commodities which are institutional commodities, which normally the normal person don't buy, which the institute will buy. So their spot market is very strong. So future market cannot dominate. In that case, the spot market dominates. Okay, now if you think from the equity market, in equity market, we are having two concepts. Suppose Nifty and Nifty future. Now, if I ask you to think whether the Nifty is dominating or the Nifty future is dominating. So most of you have thinking like this, that Nifty future is dominating. No, Nifty is dominating. Why? Because Nifty changes according to the news which comes about the companies. Nifty is a combination of 50 companies. So whatever news comes about the companies, according to that, Nifty takes this position. So basically the Nifty is dominating and Nifty future will compromise always. So it is a theoretical concept that in the equity market, the spot price is dominating and the future price compromises to the Nifty. So these are some of the findings that we have. And these findings are only contribution of one of the few contribution of the co-integrating relationship. So in economics even, so research scholars are doing the long-term relationship, studying the long-term relationship between like money supply and interest rate, interest rate and inflation rate, because they are holding the long-term relationship. Similarly, so in spot and future market, this disturbance, whenever a news comes, everybody take the long position in the future market. So this disturbance also attract the arbitrators to take the benefit of arbitrage opportunity, which comes due to the disturbance. The position taken by the arbitrator will reduce the arbitrage opportunity or the mispricing of this. This process is called error correction mechanism. So in derivative market, the error correction mechanism is known as arbitrage process. And because of this arbitrage process, the spot price comes near to the future, and now there is no difference between the theoretical future price or actual future price. So they maintain the equilibrium like this. Normally, this is the future price, and this is the spot price. And sometimes we are having the disturbance because of the abnormal prices in the future price. So this is the actual data. This is the actual data, and it is a theoretical data. So whenever there is a huge jumps, so sometimes there is a huge jumps in the prices, and the spot price is found to follow that. So in total, they are maintaining the long-term relationship. So there are two types of markets in derivatives. One is called contango, and second is called normal backwardation, if you remember. So let me explain some basic things. Normally, the future price is like this, and the spot price is supposed to follow the lines. So this is the future price, and this is the spot price. Future price is supposed to be the sum of spot price plus cost of carry. And the cost of carry consisting of the interest rate and the storage cost minus convenience yield. Convenience yield is any benefit that you have from the storing the commodity. Suppose you are having the cow, the milk is the benefit. So that is called convenience yield. Interest cost here this. This is a normal market. And in the normal market, this concept is called contango. Opposite to it, sometimes what happens when you are trading in a non-seasonal commodity? Because suppose, let me give you one example. In the month of November, the corn production will take place. Corn, butta, corn will come. So corn is easily available in the market. Like mangoes are easily available in the market in the month of May and June. Similarly, the corns are available in the month of November. Today is, let's say, August, and the buyer want to buy the corns in the month of November. Buyer want to buy the corn in the month of November. So you are a seller. So you have two options. Buy the corn from the spot market, hold it and deliver. Second option is that do nothing. Wait for the November, because in November there's a lot of corn available in the market. So in the November you buy the corn, right? So there is no holding. Just wait for the November and simply deliver. So in such a market, when there is no holding, there is no cost of carry, the spot prices are more than the future price. These are the spot and this is the future. Because why spot is high? Because you don't know in the month of November whether the price will go up, whether the price will go down. There is the uncertainty. And because of this uncertainty, the spot price is normally higher than the future price. So this concept is called normal backwardation, NW. So in derivatives market, if you want to apply the co-integration, you need to know these basic concepts. So I'm explaining you the contango and error correction mechanism. Similarly, the other example, I'm giving you the other example. And it is also very easy to understand. Normally, if you understand the interest rates in different countries, interest rate in India is very high, around 7%. It is very easy to earn the interest rate of 7%, 8% in India. There are many bonds which pay you the high interest rates. But if I ask you, what is the interest rate in Japan? What is the interest rate in US? Hardly 1%. In Japan, the interest rate is normally 0%. Maximum to maximum 1%. So interest rate in different countries are different. So don't you think we have an opportunity? We raise fund from the Japan at 0%, invest in India, wait for some time, earn the interest and give the money back. So there is a huge interest rate between the countries also. On the other side, we have one more arbitrage opportunity. One, the long-term interest rate and the short-term interest rate. If I ask you that what is the interest rate for five years and what is the interest rate for 1 year, do you think the interest rate for 1 year is equal to the interest rate of 5 years? Answer is no. Normally, the interest rate on 5 year is more than the interest rate on 1 year. So what kind of arbitrage opportunity exists? Most of the market participants, so they take the loan for 1 year, deposit for 5 years, right? After 1 year, they raises another loan and pay the first loan. After second year, they take the new loan for 1 year and pay the previous loan. So in all the 5 years, you are paying 5% and earning 7%. So there is a arbitrage opportunity between the short-term interest rate and the long-term interest rate. So now the question is that what is the error correction mechanism in this? So because all the government bodies, they know this concept, so they make this difference between the short-term interest rate and long-term interest rate equal to the cost of transaction, so that nobody will move the interest like this. And the moment long-term interest rate increases, the short-term rate has to increase. Otherwise, there's a lot of arbitrage opportunities comes into this. Or whenever the long-term interest rate moves down, the short-term interest have to move down. So there is a arbitrage opportunity between the interest rate also. So there are so many examples like this. So when you want to study the long-term relationship between these variables, you need to apply the cointegration. So that's why, because cointegration is talking about the theory, actual movement in the market. So the cointegration is having a good publication potential. Publication potential is very good for the cointegration because you are working on the theory, not the mining. So after understanding the basic examples where the cointegration is applied, now we can move. Okay, so just read this. Short-term and long-term interest rate follow the random walk over the time. Sometimes they move up, move down, but the difference between them does not move. The two interest rates are linked to each other with an invisible string of limited elasticity. Whenever difference between short-term and long-term goes wider, arbitrage opportunity exists. Arbitrageurs may manage to earn almost risk-free profit by taking a long position in the market where interest rates are higher and a short position where interest rates are low, like this. So similarly, consequently, liquidity will shrink in the short-term equity while there is excess liquidity in the long-term market. This will force the interest rate again to move towards equilibrium. Okay, so I hope you understand that. So there is a long-term relationship to be maintained in this market. So cointegration, the statistical concept. Now, what is the statistical concept? So the definition of cointegration is if two or more than two variables are integrated, non-stationary, of the same order D should be greater than 0. And there exists a stationary linear combination of these variables, the variables are said to be cointegrated. Bookish definition of a stationary. So I'm just explaining you one concept. Let me explain with whiteboard. So there are few other concepts in economics which I'm trying to explain. So you know that this is the income of a businessman, and this is the consumption of the same businessman. Income and consumption. And the difference between them is known as saving. So we have saving also. Okay, so most of the businessmen want to keep the saving constant because saving is there in the format of SIP and constant or EMIs. So they normally have the constant savings. Suppose in any month, because of medical expenses, because of marriage expenses or any event expenses, the consumption moves up. It is quite possible. Now the income, the problem with income is that you cannot increase it at your choice. This is the problem. If you want that next month I will work more hard and increase the income, normally it is not possible. It depends upon the business condition. So the limitation here is that the income will not move. So maybe it will move slightly up. So you try to increase the income, but it will not rises much up. Slightly you can increase. Now this is the position of disequilibrium. And because of this position, there must be some compromise. Either the income will compromise or the consumption will compromise. The problem is that income cannot compromise. You cannot increase the income. So the next movement is like this. So we can forecast very easily that next month the consumption will drop to a significant level. So this forecasting is only possible because of cointegration. If you understand the concept of error correction will help you in forecasting the next consumption. Now, this is the simple example. I'm giving you one more example. Suppose demand and production in economics. So we are having the demand and production. And normally, yeah, this is the production. So why I keep production? So which should come up, demand or production? So my mind says that, my knowledge says that the production should be lower than the demand. So this is the production and this is the demand. Because if production will exceed the demand, the price will go down. So you have to sell it very low price. So normally the companies keep the production slightly lesser than the demand, so that they can sell at the desired price. But what happens? Suppose demand suddenly decreases. Suddenly demand decreases because of the corona or any other problem. It is quite possible that demand decreases because demand is market driven. Because of some event, demand may decrease. So now this position is called disturbance. And because of this disturbance, either the demand has to go up or the production has to go down. Otherwise, they cannot maintain the long-term relationship. So this is you can assume that these are the lady and the dog. So dog want to move in this direction and production want to move in this direction. It is not possible. Somebody has to compromise. Because demand will not compromise the production, theory say that all the companies start cutting the cost, start layoffing, so they start giving the pink slips to the people, and they started cutting the production. So we can forecast very easily that because of the decrease in demand, the production has to cut down. And because of this cut down production, so many people lost their job. So because of that forecasting. And all the economists, they normally have the deep understanding of all this concept. They can keep eye on the demand and the production. And with any change in the demand, they can forecast that how many people will lose their job. So all these examples are having the error correction mechanism. So these error correction mechanism can be studied by cointegration. So I think I gave many examples on cointegration. So let's move to the technical side. So this is the same thing I explained in the chart. Now the technical part. We say that y and x, one variable is y and one variable is x. They are maintaining the long-term relationship right? Like this. So we assume that y is non-stationary, x is non-stationary, but the error between them, this is the ut, must be stationary. And after long-term relationship, we define the long-term relationship by the error correction. Ut minus 1 is the error which comes yesterday. So we are taking the ut minus 1 is the error, and this is the error of this equation, combined equation. And ut minus 1, because it is the error of the last day, so somebody has to correct this error. Now the question is, who is correcting? Y is correcting or x is correcting? It depends upon the theta 1 and theta 2. If theta 1 is very high, it means y is correcting this error. If theta 2 is very high, then x is correcting this error. So we will run both the equations and find out which variable is actually correcting the error. So this equations is known as Granger representation theorem. And these equations are known as error correction models. So whenever you want to apply co-integration, the error correction mechanism is the soul of the technique. Without explaining the concept of error correction, long-term possible is not there. Long-term relationship is not possible. So one thing which I'm telling you here, whenever you want to study the long-term relationship between the variables, it is impossible without understanding the error correction mechanism. So you cannot apply co-integration without understanding the error correction mechanism. If you apply co-integration without explaining the error correction mechanism, co-integration is having no meaning. Okay, so there are two tests of doing it. Initially we are having the Angel-Granger test. They initially gave this test. So they say that this is the Angel-Granger test. Let me explain you that very easy test. First, number one, there are 4 steps. Test whether both the variable follow I1 process. So first of all, we have to apply the unit root, and we have to check whether both are non-stationary or stationary. So we have to confirm that both the series are non-stationary in nature. Then estimate a regression equation like this. Then save the residual terms. Save the residual terms. If residual is stationary, it means co-integration is there. So you can check if ut is stationary, the above equation between x and y is a co-integrating equation. And in this situation, beta is known as co-integrating parameter, and 1 minus beta is called co-integration vector. Whenever we apply the error correction mechanism, we have to find out the speed of adjustment. So that I will explain you. This is the old test. Nobody applying this test nowadays. So because this test is having many problems, so now we are moving to the other test that is called okay. So this is the continuation of error Granger test. So we can apply the error correction mechanism by applying these 2 equations, where yt is the next change in y after the previous error term. Ut minus 1 is the error term of the yesterday, and how delta x means change in x. How y changes because of this error, how x changes because of this error, will tell you the error correction mechanism. And it is expected that both should move in this opposite direction, because both are correcting the error. Whenever the disturbance comes, like in consumption income case, income is also trying to correct the error. So income will go up. Consumption is also trying to correct the error. So consumption will go down. So this is the conclusion that both the variables should move in opposite direction because of the error correction mechanism. Right? So this is one of the conditions that we have to check. So since ut minus 1 represent unexpected movement in y, to restore the equilibrium, either y will move in opposite direction of ut or x will move in the direction of ut. So therefore, the expected sign of theta 1 is negative and theta 2 sign is positive. So we have to check this error correction mechanism carefully. Okay. Now we are having another test called vector error correction model. So the error correction model is using the concept of VAR, but with a new addition. So let me explain this concept. A very interesting concept. Okay. Now let me explain the VAR first. Normally in VAR, it is called YT equal to alpha plus I am leaving this space, and this is the past values of y plus past values of x and z. So this is the VAR. Now to make it VECM, we are making a new addition. That is the theta1 into ut minus 1. So this new addition in vector auto regression model is known as error correction. So we can simply say that when we add the concept of error correction in VAR, it is called vector error correction model. So what is VECM? VECM is the extension of VAR with a new addition, which is known as error correction mechanism. So the theta is telling you the impact of ut minus 1. So we will add ut minus 1 in y also, in x also, in z also. So I hope you understand this concept that VECM is the extension of VAR. In VECM, not only we can study the error correction, we can also study the causality. So this is also there. हम causality भी study कर सकते हैं और error correction भी study कर सकते हैं. So both we can study. So this is the advantage of VECM. We are having the error correction as well as causality both. However, in VAR we are having only the causality. So this is the equations of VECM where we added the new terms. So these are the new additions in the VECM as compared to VAR. Yeah. So these are the new additions. If you remove the red circle, it becomes simply VAR. And by adding it, now it is VECM. Okay. So this is the concept of VECM, vector error correction model, and which is the soul of cointegration. Now the second test, which is the most prominent test of today, is Johansson cointegration test. So Johansson cointegration test uses the matrix algebra to run the system, because Angel Granger run the system by applying simple regression model, and Johansson cointegration test is using the linear algebra and apply the eigenvalue test and the trace test. So there are two tests they applied. One is trace test and maximum eigenvalue test, and these two tests will tell you whether the cointegration is there or not. So mathematics is slightly complicated. We cannot discuss that. Okay. So this Johansson cointegration is based on the H matrix, which calculate the eigenvalue as well as rank of the matrix. So a few things which are very important in this, which is eigenvalue, rank test. On the basis of the eigenvalues and the rank test, so there are two tests in Johansson cointegration. And these tests will tell you whether the cointegration is there or not. So the one is called maximum test, max, and second is called trace test. And if the p-value, the null hypothesis of maximum test and the trace test is there is no cointegration between the series. There is no cointegration between the series. And if p-value is found to be less than 0.05, it means the cointegration is significant. So we have to check the p-value of both maximum test and the trace test. And if p-value is more than 0.05, it means there is no cointegration. If it is less than 0.05, it means there is a cointegration. After that, we are having some assumptions because there is a different type of cointegration. Number one is that no intercept in trend, intercept without co-integration trend. And I found that most of these scholars don't know how to use this assumption. So let me explain that. In this case, you can see that there is no intercept. Okay. Or let me explain in simple language. Let me explain in simple language. Okay. So what it means. So I told you that there is a movement of X and Y randomly. Suppose they are moving like this. So sometimes X moves up, sometimes Y moves up. This is called no intercept. No intercept. Condition number one. After that, if they are moving like this and they are maintaining the like this, most of the time they are maintaining this gap. Sometimes they can overlap, but most of the time they are maintaining this constant difference between the two. That is called intercept. So intercept means constant difference between the two. This is called intercept. Now the third case is that you are having the movement like this, and the movement is moving. Now what you can see here, observe here, the distance between X and Y is very small here. It is increasing slowly and slowly. The difference between X and Y increases slowly and slowly. This concept in co-integration is known as intercept plus trend. So you have to check very clearly that whether which case we have to apply. So now I think you understand what is the difference between them. Let me show you the graph. So if you have this kind of movement of X and Y, so you can see that there is a intercept in co-integration space. Similarly, right, this is intercept without restriction. Intercept is there. This is the another same case. We are having the intercept. Now, if you see, the difference between X and Y is very small in the beginning, but it is increasing with time. So this is called trend in co-integrating space. So yeah, this is these are the different other cases, but we are having these cases: no intercept and trend. Intercept without co-integrating restrictions means they are moving up. Intercept with co-integrating restriction. Intercept and trend like this. So you have to identify that which case is there in the movement of X and Y. Accordingly, you can make the choice, because there are 5 assumptions, and most of the cases the scholar go with assumption number 3. Because in most of these series, we found that there is an intercept with co-integrating restriction, and but if you have the trend also in the movement, so you should go for 4 or 5, option number 5. So like these are the movements I shown you, and there is one principle which is explaining the assumptions. You can go for pendulum principle. So first move 1, then 2, then 3, then 4, then 5, and check when the null hypothesis is rejected. So whenever the hypothesis is rejected, you can accept that. So this is the simple concept. If you don't know the concept of all the 5 assumptions, so most of these scholars, what they do, they check the different assumptions and stop where the hypothesis is rejected. Okay. So then once we examine the co-integration, the next movement is to move to the VECM. VECM, vector error correction model. Normally, I follow these steps. These are the steps that we have to follow in running the VECM. Identify that the time series are non-stationary of the same order. Apply Johansson co-integration test, assumption and the lag. We have to check with different assumptions and the different lags, because these two are playing a very important role. If you change it, the hypothesis testing will change. Arrange the series in the order of exogeneity as we do in VAR. Identify the optimum lag length. Find out the speed of adjustment and what is the error correction mechanism. So analyze this. Apply block exogeneity test for short-term causality. Impulse response function, variance decomposition, forecasting and validation. So these are the steps that we do in VAR also, and the same step we are doing the VECM. Okay. So my theoretical explanation of cointegration is done. Now I'm moving to the software part. I'm using eViews. Let me try to eViews 12. So I'm opening the data. Open foreign trace work file. So I'm taking the spot and future market of Brazil. In one of the paper, I use this. So we are having the spot price of Brazil stock index, that is called Bovespa, and the future. So first of all, I just open this page, identify that whether the time series are non-stationary of the same order or not. So we have to check the spot price, unit to test, standard unit to test at trend and intercept level, ADF test, okay, found to be non-stationary. Similarly, future, view, unit route, standard unit route, trend and intercept, okay, found to be non-stationary. So both the series are found to be non-stationary. So let's check whether they are stationary at level or not. So we can apply d-log of future equal to d-log future, and similarly I can apply another equation, d-log spot equal to d-log spot. So we are having both d-log future, check unit to test, okay, and you see that is stationary. So it is I1 series. Similarly, d-log spot, and it is also I1 series. So both the series are I1. We can apply cointegration between them. So this is the first step number 1. Now you select spot and future. Now we are working on the original series, not the d-log series. Open as a group. So you have both spot and future, and make the graph of it to check the intercept or not. Okay, so they are just overlapping to each other. So we are having the maybe intercept or not, can't. We are not clear on this graph also. Okay, so now go to cointegration test. Now go to cointegration test. In cointegration test, you can see there are two options: single equation cointegration test and Johansson system cointegration test. Single equation cointegration test was provided by Angel and Granger. So we should apply on this. First of all, the test method is Angel and Granger. Lag specification is automatic. So just click OK. Trend specification depends upon you. I put it constant and OK. The null hypothesis of Angel and Granger test is series are not cointegrated. The probability is saying that no, they are cointegrated. So they are cointegrated. If you assume spot is a dependent variable, cointegrated. Future is a dependent variable, cointegrated. So series is cointegrated. And after that, you have to save the residuals. So we must have residuals of this equation. Okay. Intermediate results. Yeah. So this is simple Engel-Granger test and saying that they are cointegrated. So we are not having the options of saving the residuals here. Okay, so directly we can go to another test, Johansson cointegration test, because Engel-Granger test we are not applying any. Most of the time we are applying the Johansson system cointegration test. So that is more important. Now, if we click on this, the two things which we need to decide. Number one, lag interval. So that is very, very important part, lag interval. And second, you can see that there are first assumption, no intercept or trend. Intercept in co-integrating space. Third, intercept but no trend. Intercept and trend. So you have to be very, very careful in taking these assumptions because they can change your results. So by looking at the graph of spot and future, I am assuming the intercept but no trend. So this is the most popular assumption. And taking the lag of 4. Okay. So what kind of result you should have? The first is called trace test. This test is not trace test. And there are two hypotheses. Number one, there is no co-integrating and we are rejecting that. At most one, we are accepting that this is alternate hypothesis. So we are testing both the null hypothesis and the alternate hypothesis at the same time. So the null hypothesis is rejecting. Alternate hypothesis, we are accepting. So it means there exists significant co-integration between the two. Similarly, if you go for maximum eigenvalue test, so I told you that there are two tests, trace test and maximum eigenvalue test, and both the tests are reported in the paper. This test is also saying that there is no co-integration. We are rejecting this hypothesis. No co-integration, rejecting the hypothesis. Co-integration, accepting the hypothesis. So final conclusion is that there exists significant co-integrating relationship between the two. Johansson co-integration test will only tell you this thing, that whether the two series are co-integrating or not. So now we know that the two series are co-integrated. So once we know that two series are co-integrated, then we can go to VECM. If they are not co-integrated, we can go to VAR, but not VECM. So now we are having clarity that both the series are co-integrated. Okay, now let's close it. We are moving again back to the series. Now we are opening them as a VAR. Because once we confirm that the series are co-integrated, the next moment is to check the VECM model. So we are going to apply vector error correction. You have to convert this vector error correction and don't remember that they should be non-stationary. Don't take log values here. Because I have seen that some scholars take the d-log spot, d-log is future here. That is wrong thing. So you have to take only maximum. You can take log. That is not a problem. Log you can take because taking log will not change them into stationary. So up to log you can take and assume that now think for how many days error must be corrected. So let's assume 8 and we have to finalize that at which lag we should stop. So these are some of the preliminary things that we need to check. After that, just click OK. And we have to find out that which is more exogenous. So first value should be of R square. The first value should be the lowest. Second value should be the highest. So I think we are having fine in that 0.012 and 0.18 is fine. The first value is lowest. Now we are examining the lag structure. We don't have lag length criteria here. We have lag exclusion criteria here. So the question is that how many lag we should consider. See the individual as well as joint. So jointly it is significant. You can see that these two are insignificant individually, but jointly they are significant. So we have to consider joint. Significant, significant, significant. But here it is, you can see that it is insignificant. So the moment joint probability is insignificant, we should stop here. Because this is significant, this is significant, it's significant. No, they are by chance. So we have to stop at 4 lag. So how many lag we have to select? Only 3. because at 4 it is joint probability is insignificant. So we have to take how much? 3. So I am converting the lag of 3. So in this way, first of all, we have to decide the lag length criteria in VECM. Okay. Now I have to analyze two aspects. One is error correction and second is the causality. This equation, this part of the equation is representing the error correction model. This red box is showing you the error correction mechanism, which is the most important part of cointegration. Now, first of all, we have to check whether the sign of the two are opposite. Yes. The first thing I need to check here, whether X and Y have opposite signs. The answer is yes. Okay. Now, second question is, the value in square bracket are T statistics. T statistics. So we have to check how many of them are more than 1.96. If both are more than 1.96, it means both are correcting the error. If only one sign is more than 1.96, it means only one side correction is there. So in this case, one value is more than 1.96 and other value is on the borderline. So we are very, very sure that the future is correcting the error, is compromising. So I'm writing that compromising. Because in equity market, most of the time we found that the future is compromising the spot market. So now I can conclude that the future market is compromising the spot market in equity market. So this is my conclusion. So, and I have to report this value in the paper. This part is very, very important. So I explained you, and yeah, one more thing. So you can see that 0.09. This is known as speed of adjustment. So speed of adjustment in future is higher than the speed of adjustment in spot. So future market is adjusting the error quickly as compared to the speed of adjustment of the spot. So we have to explain also these terms in terms of speed of adjustment. So where here they are similar to each other, but it is a fact that the speed of adjustment is higher in case of future and it is significant too. However, it is not significant. So by carefully, you have to analyze all these things. After that, I hope you got it. After that, we can go for causality. The same way we'll do in bar. We can go to the leg structure, leg causality. And here we can conclude that there exists error correction only by one side. So we can say it is a unidirectional causality. So it is causality, unidirectional causality. So here the direction of the causality is spot to future. However, it is not future to spot. So the causality is in the direction of spot to future. So if any change comes in spot, future will respond to it. So spot is said to be the exogenous independent and future is said to be endo dependent. So this is the nature of causality, and it is not long-term causality, it is called short-term causality. So the short-term causality exists in the direction of spot to future. Spot is exogenous because it is independent and future is endogenous because it depends upon the movement in the spot. So we can make a theory that in the equity market, we are having two markets, spot and future. So the spot market is dominating and future market is compromising. So whenever a new information comes, most of the traders take position in the spot market and future will follow the spot market movement. So this is the concept we explained in cointegration. Okay, after that, now we can move to the impulse response function. So I can show how the correction takes place. In impulse definition, go to generalized impulses, and these are the movements. Spot to spot, remove. Future to future, remove. So we know that the future to spot is more significant as compared to spot to future. Magnitude wise, it is 176 and it is 172, and it is slightly higher than 177. So more impact is coming from the future to spot. And you can also click on accumulated, so that in accumulated, normally we keep the time period very high. Oh my God. Okay. So it is not becoming very clear here in this data set. So better to not go for accumulation, go for 5 here and show that this is the movement of impulse response function. When you show impulse response function, remove this, and show these two variables. And showing that the 176 is higher than 172, it is found to be insignificant, but it is found to be significant with respect to the response of one market to another market. Similarly, we can go for variance decomposition, 5 period. So let's see decomposition. Okay. And we have to make the tables. So the spot is explained 99% by itself, only 0.12% by future. However, future is explained 96% by itself and 3.6% by future. So 90, you can see that log of future is explained how much times by spot? 96 times. So 96% movement in the future can be explained by the spot. Too high. And future not explained by itself. So this is the clear picture of, and you can make this graph or stack graph, I think, yeah. So any of the graph you can apply multiple graphs, but normally we report the tables in the paper that this is the impact of one series on another series. So in simple language, spot is not explained by the future, only by 0.12%. However, future can be explained by the spot of by 96%. So future is totally compromising the spot. All the pictures and all the graphs indicate that the future series in the stock market is compromising the spot price. So this is the one example of co-integration. Tomorrow I will do another example, and I will also try to incorporate R in co-integration. So in co-integration, we are having very strong commands in R. So I will also show you that. So for today's lecture, I think that's it. I explained each and every concept of co-integration, which you must know. And tomorrow we will do more practice, and we'll do in R also.